And good evening. Let's solve an example in aquifer, unconfined aquifer, which we had just driven the mathematical equation for unconfined aquifer. And let's see, for example, if I want to draw out the water from a well, and then I have a property like by distance, for example, like in our problem, like 300 meters away from the center of our well. I just want to see if this will affect the water table in my neighborhood or not. Let's see how we can solve such problem related to unconfined aquifer. So let's jump to our problem. So like if we have a pumping well by a radius of 0.75 meters or 75 centimeters, a fully penetrate in an unconfined aquifer of a thickness of or a height of 24-meter, pumps the water at a rate of 10 liter per second. The drawdown, we do have two observation well. The drawdown from the piezometric level for the first uh, well is 1.6 from the top of 24, from the bottom of a aquifer to the piezometric or water table elevation. The drawdown is 1.6 for the first one and 1.1 meter for the second observation well. We do know the very first one locates at a distance of 30 meters from the center of the well, and we want to calculate the second observation well distance from the center line of the pumping. So by having this information, and also hydraulic conductivity of the soil is also provided to be like K, permeability coefficient of soil, or hydraulic conductivity is provided to be like 8.40 meter per day. In part A, we want to know what is the distance of the second well, so we want to know what R2 is. And then in part B, we want to know what is the expected drawdown at the pumping well, what is this distance. If this is our height of well, we want to know what is the traveling down from the piezometric level. And then in part C, assume your property or your house is located at 300 away from, this is my house, and this is just located 300 away from the 300 meters away from the center line of my pump. I do want to see if this pump affects the water table at my, let's say, neighborhood or not. Let's see how we can solve this problem. So again, the first observation well located at a distance of 30 meters from the center line of our well, and the drawdown for that is 1.6 meter. The second one located at a distance, unknown distance, which we're going to calculate by a drawdown of 1.1 from the piezometric line, and the total height of our unconfined aquifer is 24. So let's see what is the distance of the second well from the pump. If Q, we already calculated a Q for unconfined the aquifer, and first, because of the unit of K, we need to convert the Q to meter cube per day. Don't worry about this is meter per day, this is meter cube because we have a meter squared here. So this is meter times meter, it just gives meter cube per seconds, or meter cube per day. So we want to make our unit like consistent. So 10 liter per second, a conversion to a in each 1,000 liter is 1 meter cubed, and each day is equal to 24 hours times, and each hour is 3600 seconds. By doing that, it just gives us the Q, or discharge is 864 meter cube per day. So then, having that part, we just calculate H1 is just the height of first well, is the total height of aquifer minus the drawdown of the first one, and likewise for the second one, we get H1 is equal to 22.4 meters and H2 is equal to 22.9 meters. Replacing H1 and H2 in our equation, it just gives us Q is equal to K times pi times H2 squared minus H1 squared over ln R2, which is we are going to calculate this unknown distance. So if you do so, it just gives you ln of R2 over 30 is equal to this number. And if we just call that x, ln of x is equal to this number, and then it goes to Neperian, x is equal to e to the power of this number, and it just gives us x is equal to 2.00, oh, it's almost 2. X, and x was R2 over 30. And it just gives me the distance of the second observation well, which is 60 meters from the center of pumping. In the other part of the problem, we want to know what is the drawdown at the well. So if this is my height of the well, then total height minus this height is just my drawdown or drops of the water height. So for drawing in pumping well, drawdown in pumping well, we do need to subtract 24 minus height of well, which we are going to calculate H sub W. So for doing this part, it just gives us a, you can use either of the observation well to calculate the height of. So for calculating H of W, you can use either of H1 or H2. We just use H2. You can use the other one. It gives you the same exact answer. So if you jot down the relation of unconfined aquifer, again, the discharge is equal to hydraulic conductivity times pi. For the second one, this is 24 minus 1.1, that's H2 squared minus HW squared over R2 over RW, which is 60. We just calculate R2 is 60 meters in previous part, and if you do so, it just gives you HW is equal to 19.53 meters. And then the drawdown, the drop of water, definitely is equal to 24 minus 19.5. It just gives you the numeric value of 4.47 meters of water in terms of the drawdown at the pumping well itself. And in the last part, we just assume I do have a house. My home is located in a 300 meters away from the center of the pump. I just want to know if this pumping affects my water table in my neighborhood. So let's see how we can calculate that one. So in this time, we use a concept or distance like R naught, which is the radius of influence. If I'm out of the radius of influence, so that well is not affecting my property, and also in terms of the lowering the water piezometric level of water table in my adjacent area, or if I am within the R naught or radius of influence of that well, so definitely my water is also dropping. So let's see how we can solve this part. So again, I'm writing down the equation of unconfined aquifer. This is my discharge is equal to K pi. I'm using H naught. And also that's H naught squared minus HW squared, height of the well itself, because I already calculated height of the well. You can also use any other these two observation well as well. So if you write down that, it just gives you ln of r naught over 0.75, which is rw. It just gives you this numeric value. E to the power of that is our x, and x is equal to 386, and this number is 300. But be careful, r naught over x is equal to r naught over a 0.75, which is rw, radius of, and if you multiply that by 0.75, it just gives you radius of influence is equal to 290 meters, and definitely that's less than my house distance. And fortunately, this pumping, it doesn't have any negative effect on my property. So that was a practical example in a unconfined aquifer. Will derive the equation of confined aquifer, and will solve a numeric example in that one as well. Thank you. Have a good week.